Howdy, it's Mr. Pete and welcome back to my channel, and this is part 4 of the 2 by 48 inch belt sander build, and there'll be at least one more part after this, so be sure and check out the other ones or this may not make any sense to you. So I've done the wheels, I've done the base, talked about the motor and the end bracket and a few things like that. So what we're going to do next is to build the upright shaft here and the tensioning mechanism. So let's get started with that. Alright, here's what I did on the prototype. Notice that this is a piece of 1-inch round tubing, and I think that's your best bet, and it looks like this. It's a 1-inch OD, it's 3/4 ID. This is not pipe, this is tubing. I don't know where I got it, I don't know where you can get it, but that is really what you ought to have, and you can see that a piece of 3/4 stock is going to fit in there quite nicely. It's quite a stiff spring in here, but that's what gives it the belt tension. Remember, this is to be cut off. This one never was quite finished. But that's essentially what we're doing here, is round tubing with a 3/4 shaft in it. Now, when I made the prototype, I started out with square tubing. And you can see that I even had it mounted, and then instead of round tubing in there, or a round shaft, it was square shaft. Where is it? Like that. And that still is a possibility for you. So this is, and that's not a real good fit, and you're always going to have trouble with tubing, square tubing, because the corners on the inside are radius, they're round, the same as they're round on the outside. But anyway, you probably can do something with that, but if you do, you'll have to have a different type of tracking mechanism than what I have here. Possibly I'll show a little clip or suggestion for how you might track it if you use square tubing rather than the round tubing, but I am going to forge ahead with the round. I only had about 2.5 feet of this. So this particular piece is, let's see, well, it's 12 inches long is what it is. How amazing is that? I'm out in the garage right now, and this is the Mead band sander, and there'll be videos on this later on, but I don't want to get too sidetracked. But this is a 1 by 42 inch band sander, I'm going to call it, but the tracking device here is what you might have to use if you're going to use the square tubing method. But all this is the shaft is supported on each end. That's a much smaller shaft, and there are really 2 screws here, 1, 2, and they work up against one another to allow this shaft to tilt like that. And when you find the sweet spot where the belt tracks on the wheel, then you tighten the 2 up against one another and lock it. But that is a method that has been used for many, many years for tracking belts. So take that into consideration. Well, it's the next day, and I couldn't sleep at all last night. I kept tossing and turning, and during that time I do a lot of thinking. And that is in regards to how I'm mounting this. You know what, I'll get back to this thought here in a few minutes, because it's already a non sequitur, I think. So this is back from the paint shop. That didn't cost too much. The holes are drilled and it's all ready to go, or at least that part is. But what I was talking about yesterday was tracking, so let me get back to that and show you how Kalamazoo did it and how I'm going to do it. You know, I just had a funny thought, at least it's funny to me. I talk about Tommy the spite mower all the time. And my furnace turned out to be a spite furnace. Every time I turn the camera on, it kicks in. So then I have to run over there and turn the power off. Then I forget. I go upstairs and about 3 hours later I'm there, you know what, hon, it sure is chilly in there. And then it dawns on me, you know, my memory is just terrible. All right, that was an aside. So I got a spite furnace and I got a spite neighbor and I got a spite air conditioner. Kalamazoo, now this is made by Kalamazoo Industries. So that's what I'm talking about when I talk about Kalamazoo. Now, whether or not that's the same company that makes the beautiful bandsaws, I don't know. I used to have bandsaws at school made by Kalamazoo. They were wonderful. All right. Even if the two wheels are in line vertically, and I'm sure they are on this commercially built one, and we have crown on the wheels, what keeps the belt running straight and from coming off the wheels? Well, it has to be aligned. It's the same as a bandsaw does, and you've all dealt with that probably. So let me turn this on and show you how this works. And I'm scared to death working around these belts, because you know, if you run your hand or finger into the edge of a belt, boy, you'd get a nasty cut. So this knob, when loosened, allows you to it allows me. It doesn't allow you anything. See how I can turn this back and forth just a little bit. Not a whole lot, but that's what allows me to track it. So let me turn it on if I can, and we'll see what happens. With the machine running, watch what happens now. So I find the best spot where it's tracking, and then I lock it down. So that's exactly what I'm going to do with mine. So here I am with mine, and I have the bolt loosened. And see how I can move it back and forth? And then I tighten it, of course, in the spots that I want to. Now, of course, this is the prototype, so this isn't finished, and a couple changes I'm going to make. And one is I absolutely need to have the bolt on this side like Kalamazoo did, because it's just wicked working in here. Plus, there might be a cover on this. I'm not sure yet. So, I will have a knob, something like that, but I'll have to use a fine thread, I believe. So, there's my other knob that I'll more than likely use. That must be government issue. So the knob will be over here. So you understand now how I'm going to go about tracking it. All right, enough of that for now. While I was struggling with my insomnia, and I've had insomnia really since I was like a 10-year-old boy. I just remember not being able to sleep when the rest of the family is. So it's really been a burden in my life. Matter of fact, I can't emphasize that enough. What a hardship it is to have trouble sleeping. Some of you might be in the same situation. And then I'm exhausted the next day, as I am right now. But I must forge ahead. But anyway, boy, talk about sidetrack. Here's what I was thinking about, and this is the way that the genuine Kalamazoo is built. Looking at it from this view, they took, again, this piece, which was folded, and I still have this half, and I darn near scrapped all of yesterday's or 2 days video and decided to go this way, but I'm not going to. But I could always go back, but I probably never will. All right, let's just say that this was welded on in a vertical position. I would amputate this right about here where the little line is. Matter of fact, I already laid that out in my... All right, so weld that on like that, or an angle iron or something else, and this piece would be scrapped, and an enlarged one would come all the way over, and, well, do I have a piece here? In other words, it would extend over and come on to this piece and be welded, and it would go clear down here to the bottom. In other words, it would be longer and wider, and really would not depend on these 4 draw bolts anymore at all. They could be left in, but it wouldn't be necessary. And the motor would have to be moved out a little bit to give me that surface down here so I could weld. So do you understand what I'm talking about here? And let me just show you the side view of the Kalamazoo real quickly. Here's the genuine Kalamazoo, and take a look now how they made that. It's welded down at the bottom. Pretty poor weld, by the way. And the plate goes clear over to this part. And I'm sure it's welded back here where we can't see it. And why all of this? Of course, so it can be laid down into its horizontal position, which I never ever have used that feature on any of my sanders. I like to use the vertical movement. I think that's why for now I am not going to do this, but if I had it to do over, you see, I work without plans. I'm building this by the seat of my pants. Alright, I've got to do some actual building instead of talking. So the next step is to make this post, and I have a 12-inch piece of that, so I will cut it off to 11. This is 11. Now I'm just going by the dimensions that I developed in my prototype, and I don't even remember how I arrived at that, but that's going to be just fine. And this will be bolted onto this plate, but remember, it's going to be slightly off-center. Why? Because the top and the bottom wheel are not the same diameter. So since I'm going to bolt this on with 2 bolts, really what I want here, so I don't have a problem of it moving around, or if I'm clamping it and locating it and all of that, so what I do is to mill a little bit of a flat on here. How much? Oh, probably, this is rather thick wall tubing, but perhaps 1/4 inch wide and 3 or 4 inches long. So first of all, I'll saw this off, and then I'll meet you over at the milling machine. We'll actually make some chips. Always wear your safety glasses, and just one quick pass with that Niagara cutter down to my layout line. And that's all there is to it. And that flat is about 5/16 wide. It looks like it's not too critical, but the reason I like to do that is now when I go to clamp this on here, it's not going to roll around on me. I can get it on the flat, you see, while I make my various adjustments. But I don't know where it's supposed to go yet, and I can't do that until I get really the upper wheel in place and a belt on there, and then some of the alignment can start to take place as far as locating these holes. Now, it wouldn't be so bad if both wheels were the same diameter. Let me pull this out so I can talk about it. You can see that the end of this bolt is turned down. You'll see why in a moment. And if I can pull this out, now look, there's a keyway in here. Actually, I did it on both sides because I was experimenting. Let me start by cutting this thing off, which has been annoying me for 6 weeks. This is 3/4 cold rolled steel, and there's a piece of it about 3 feet long. I have to cut it off. And how long? Well, let's see. It's 9 inches. It could be more or less depending on the length or strength of your spring that is inside here. So originally I made this an arbitrary length, and then I trimmed it to length when I determined the amount of, oh, shall I say, tension that I wanted. That was baguesse and bagosh, but it worked fine. So there's 4 holes in this 3/4 tubing. One up here for this collar, which I think I'm going to make next. See, that comes right off. It's not even welded, and that's a verbatim copy off of the Kalamazoo. Hope they don't have a patent on it. Well, this is more than a hole. It's a slot. If I may swing that around. Can you see that's a slot? Why is it a slot, you ask? Well, so that this knob could be turned and the whole shaft turned. So that's 1/4 inch hole. That's more or less a 1/4 inch there. It just needs some clearance. And the collar is held in place by that, so it doesn't need to be welded, although, no, it can't be welded because sometimes I got to think this through, because it has to rotate as well. Boy, that's in the top of your picture, isn't it? Again, fine thread. So this hole, this slot, wants to be pretty much 180 degrees from the flat that I just milled here a few minutes ago. So down on the bottom, of course, there's 2 5/16 holes that are drilled all the way through the plate and the tubing, and that's what actually holds it on. And this 1/4 inch bolt here, I'm going to try not using that. Really, that's just a stop for the spring. In other words, the spring comes down and hits that. Now, depending on the length of the spring, that may have to be moved up one way or the other. Or if you have a real long spring, this can serve as the stop for the spring. So I'll experiment with that later on, and that isn't very critical as far as alignment. It could be even 90 degrees apart or anything in between. Let's make this collar. Well, when I made this collar, 1.5 diameter, a month or more ago, and sometimes I forget how I did this, but I very carefully and methodically laid this on the bench so I would remember. All right, anyway, it was just a piece of scrap that long, so, and it's already got a hole in there, which saves a heck of a lot of time, by the way. So I will bore a hole. I'll rough drill it and then I'll bore it. I want a nice fit on the tubing, a real nice fit. Matter of fact, I got to polish the tubing here and get that rust off in order for it to fit. So into the lathe this goes. I'll face off the one side. It's already faced. Well, I think it's been cut off. It looks pretty rough. I'll face both sides. 15/16 drill. Sometimes a simple little part like this takes a lot longer than you might think to get it down to, you know, a good fit and all of that, but I probably waste time, but that's a good fit. And what I will do off camera is drill and tap a hole in here for this, and that will be 3/8 fine, 3/8 fine, which is 3/8 24, of course. And 3/8 24 it is. Just like downtown. There was a gun tap. Sometimes I forget that I have a set of these taps and tap drills, and these are the fine, in the Hewitt container. I'm running around chasing drill bits and looking up sizes and all that, and you know, it's all right there. Anyway, a 1-inch reamer takes the burr out from the inside, and that piece, for all intents and purposes, is done. And now for the knob out of my junk pile. It just happens to have a 3/8 hole, and there's a 3/8 fine bolt, and for once it's not a grade 5, it's just a soft one, so it'll be easy for me to turn it down 1/4 inch diameter. I won't even show that, and I'll have to cut it off the length. Then I will put it in here like that. I'll leave the head on it and pin it. Now somebody from the factory evidently had an 1/8 inch hole. I'll drill that at right angles to that all the way through and drive in a roll pin, and that's all it takes, and I won't do that on camera. I'm out in the garage, and this is the closing mill. You've seen the videos on that, and this is the inaugural run. And I'm going to cut the keyway in that shaft that holds the upper wheel. I've already got the setup made. There's a 1/4 inch cutter in there. I've located it, I've clamped the work, and I'm ready to make chips. And here I go, the first chips. That's a 1/4 inch wide cutter, about 3 inches in diameter. It's a 70,000th depth of cut, 450 RPM, power feed of about 5/8 of an inch per foot. I'll have to get used to the speeds and feeds. Probably could run it a lot faster. It's a very dull cutter, putting up quite a large burr, and this is my third and last pass. I'm about 1/8 of an inch deep. Not too critical. Alright, that completes the cut. It sure took a lot longer to do this than it would have on the Bridgeport, but I wanted to try it out. Notice how I've got it clamped on both ends so the clamps are not in the way. I'm not using a vise. I don't have a vise yet. It's on the way from Texas. I have the work directly in the T-slot, which assures that it's perfectly in alignment. And now I'll take it off and let's go back down in the shop. I'm back in the basement shop, and that's what it looks like. There was a lot of deburring to do. I told you that cutter, it was the only 1/4 inch wide one that I had in that big batch from Chuck, but it happened to be fairly dull. So I hope I have this located in the correct position. Now this piece is still too long, and there'll be a hole drilled and tapped in the top, and that the purpose of that is for the guard. So in the meantime, I also pinned this threaded bolt with a 1/8 inch roll pin. You know I'm not showing every last operation and step here. It just isn't practical, probably. I told you that thing rings like a bell, and that's what happens when we're turning. I don't know if you can hear that or not, but the vibration causes chatter. Alright, I've already located these two holes, and I located those similar to the way I did this as far as getting them on center. I did that in the milling machine. You can see that they turned out fine, and the distance here and here was determined by just setting it on the work. Over on the Bridgeport mill now, I'm just going to take a minute to describe this operation. On the top of the tube now, I want that 1/4 inch diameter slot that's about 5/8 long. And how am I going to locate that so it's basically 180 degrees from the flat on the other side? Well, what I came up with here, I've got a parallel in the vise, and I've got this leveling block here set at exactly that same height, and this isn't all that critical, but by laying the flat on this surface and then tightening it down, I have determined that I am, as Popeye would say, I am what I am on the flat, ready to mill. And then on the end with the slot, I've already pierced the work, and now I need to just go back and forth in the y-axis to my layout lines for a total width of 5/8. And that's all there is to it. 30 seconds worth of cutting, 20 minutes worth of setup. Here's my initial setup. Now don't panic. This is the wheel and upper rod from the other one there, the prototype. I, of course, am going to fit it with this one. Just wanted to see how it would fit up, and then notice right here, with the clamp on there, that flat spot on the post is clamped up against this. Now I haven't located it yet, but it will be off center because of the difference in diameter of the two wheels. Also, I want to make sure this is perfectly vertical. And one other step, if I can grab my great big square. Looking at it from this direction now, using the Brown and Sharp square, this is not up against the wheel. It is against this wheel, so the alignment is not right yet. This is just baguesse and bagosh right now. but I will move the post over to get that alignment, but I also want the post, as I just mentioned, to remain vertical. The back of this wheel and this wheel will not be in alignment. They will not be if I check them with a square. So I only care about the front. And that's the way the Kalamazoo is made. So there are several things that I'm trying to do here at the same time, and then locate and drill the two holes that'll hold the post on. Also, and I'm going to do that all off camera. I'm just explaining how I'm going to do it because that's kind of a laborious process. This is the post that I just milled, and I have to determine where I'm going to locate that upper axle shaft for this. And I'll drill and tap that. No, not. I should say just drill it on the milling machine. All right, looking at it from this angle now, on the upper post here, that is a threaded hole, 5/16 18, and there's a set screw in there. You can't see it, and that set screw is holding the upper half-inch axle in place. And then the rest of the thread here, and that's the reason this is extra long. You wouldn't think it would need it to be that long, other than that will serve as a threaded hole to hold this wheel guard, and you can see there's a cap screw right here. All right, this old man is kind of tired. I've been working at this all day, so that will conclude this particular part, which is part 4 of the build of the 2x48 clone Kalamazoo. This is tubalcain saying so long for now, and I'll see you tomorrow in part 5.